Hey guys, welcome to my channel. I'm Genie Coder, and today we have a pretty interesting video for you guys, right? We're gonna be going over depth first search, right, or DFS for short, right? So depth first search, guys, is an algorithm, right, that's used for searching or traversing a tree or a graph, right? Pretty much it's a very efficient way of doing things, right? So pretty much it prioritizes going as deep as possible, right? Depth first search, what I'm saying. So it goes as deep as possible along each path, right? And then backtracks and then visits other paths, right? That may be in the structure, right? So we've used DFS a lot on tree problems on this channel. So we're kind of comfortable with the whole idea of depth first search, right? We normally do it recursively, guys, what I'm saying, which uses a stack implicitly, right? So, which is the function call stack, right? So right now, as you guys can see in the picture I have, right? This is we're going to be using an actual stack, right, to kind of simulate that, I'm saying. Yeah, you could use it recursively as well. So pretty much the idea is the same for a graph, right? The only difference now, guys, we're going to be using a set, right? So set or other data structure you have, right, that pretty much let us know if a node has been visited before, right? So that's the only difference, right, I'm saying. So that data structure, that additional data structure, I'm saying, that's going to be used pretty much to help us and knowing which nodes, right, we've already visited, so we don't end up in an infinite loop, right, I'm saying, because we don't want that, I'm saying. So for the tree one, right, we don't have to worry about cycles, so that's why we don't use a set when we do the whole breadth, the whole depth first search, pretty much, right? So yeah, so let's get started with this, right? So I told you guys we're going to be using a set, right, I'm saying, to pretty much let us know which nodes that we've already visited before, so we don't revisit them again. You know what I'm saying? So pretty much we're gonna have a couple of things, right? So I'm gonna have a current node variable right there, so that it can let us know that which node that we're currently on, right? So it's kind of clear to you guys, so you guys can actually understand what's going on, right? And then we're also gonna have, guys, current node, and then we're also gonna have what? The set that I talked about, right? Pretty much let us know the nodes that we've already visited, you know what I'm saying. So yeah, so the stack is up there, right? So as we visit the nodes, guys, now when they get visited, right, we're gonna print them, right? I'm saying we could do whatever processing you wanted to do, but just for simplicity, right, we're gonna have a simple operation, simple task, right? We must print yourself, right? Every node when you get visited, please print yourself, right? That's all you need to do, right? Keeping it simple. All right, so yeah, so it's just a way for it to traverse. That's all that DFS is, I'm saying. So let's get started, right? So pretty much we're gonna need to start at the root node, what I'm saying. For this case, the root node can be whatever node that you want it to be, you know what I'm saying. But for simplicity, we're gonna start off with 0 as the root node, right? You know what I'm saying. So so we add 0 to the stack, right? 0 gets added, right? You know what I'm saying. We add 0 to the stack, right? So now we need to start doing processing, right? So now we're gonna pop 0 off the stack, right? So current node is gonna be 0, right? You know what I'm saying. That's the current node that we're on right now, right? And we also need to add 0 to the set, right, to let us know that we visited 0, I'm saying. And now 0 it's gonna add all of its neighbors, right, I'm saying. So make sure that I print 0 right there, so it's clear to you guys, right? Print 0, right? So it gets printed. So now 0 got all its neighbors, right? So we see one neighbor, which is 1, right? You know what I'm saying 1 is the only neighbor of 0, right? That's the only node that's adjacent to 0, you know what I'm saying. So we add 1 to the stack, right? Right, and then there are no more neighbors. So now we visit the next node, right? The next node, guys, is gonna be 1, right? So current node is gonna change to a 1, right? Because 1 is the one at the top of the stack right now, right? You know what I'm saying. So our current node is 1, right? And then we also need to add 1 to the set, right? We add 1 to the set. And then we also need to make sure to print 1, right? Because we said every node, please print yourself, right? So so yeah, so current node 1 and node now 1, right? It's gonna visit all of its neighbors, right? So we got 0 as a node that's adjacent to 1, right? We got 2 as a node that's adjacent to 1. We got 3 that's adjacent to 1, right? So we got 3 node that's adjacent to this node, right? So that's a very good case, right? So pretty much we add all of our neighbors, right? Like I told you guys, right? I'm saying we add we could add them 0, we add 2, and we add 3, right? Okay, so we add all of our neighbors, right? Which was 0, 0, 2, and 3, right? So we added them to the stack, right? So now we're done. So now we go on to the next one, right? So 3 is the next node that we're gonna visit, right? So we check that 3 is not in the set, right? I'm saying 3 is not in the set, and yeah, so we could visit 3, right? So current node is going to be changed, right? So now current node is 3, right? So 3 gets popped up the stack, right? And then I told you guys every node is going to print themselves, right? So we print 3, right? So we print 3, right? And then we also need to add 3 to the set, right? And then 3 is going to do the same thing, guys, add all of its neighbors, right? So it has 2 neighbors, which is 1 and 2, right? It's 1 and 2, that's all it has, right? And so now that's exactly what 3 is going to do, right? It's going to add it has 1 and 2, right? 3 has 1 and 2 as the neighbor. So we add 1, and then we add 2, right? Right, and then so we added all of its neighbors, and then we we go on to the next one, and then now 2 is the next one, right? So 2 is not in the set, right? So we can visit 2, right? So since we can visit 2, we're gonna pop off 2 off the stack, right? I'm saying, because we always get the thing at the top of the stack, right? Because we want the last in, first out, right? I'm saying that's the whole depth first search thing, right? So take 2 out. Remember, when we take them out, we add them to the set, right? We will make sure we do that. And then also make sure that we print ourselves, right? Okay, we printed ourselves right there. And yeah, and then 2 is pretty much gonna visit all of its neighbors, add all its neighbors to the stack, right? So they could be visited as well, right? So there's 2 neighbors, right? 1 and 3, right? Because of the edges connecting them, right? That's how I'm doing it. So make sure that's clear to you guys, right? So 2 is gonna add 3 and 1, right? So now yeah, so there's no more nodes. So now we see we got a whole bunch of stuff in the stack, right? Don't worry, we're gonna take care of them, all right? So pretty much we gotta take 1 of the stack, right? I'm saying, so 1 gets it taken off the stack, right? And then make sure I erase it. Okay, so we take 1 out, and then 1 is already included in the set, right? So the set is gonna let us know if the node has been visited, right? So 1 has already been visited before, right? So yeah, we're gonna skip it, right? I'm saying, so yeah, and then we go on to the next one, right? 3 is the next node, right? 3 is already in the set, right? So we don't visit again, right? And then we encounter a 1 again, right? We don't visit again. I'm saying, same thing, right? So 1, we pop off 1 while the stack rests 1 bit visited. Okay, we erase that. Next node, 2, right? 2 has already been visited, guys. So we don't need to visit that again, right? We skip it. 0 already been visited, guys. So we not worry about it. And the stack is empty, guys. So we would exit. And then yeah, so that's 1 path, guys, that we have here, right? Oh, sorry. We just pretty much printed one of the paths right there, guys. What I'm saying, that's one of the paths that we have here, guys. So pretty cool. So right now we're gonna jump into the code, right? So like obviously, you know, we there are other paths we can have. We could have 0, 0, 1, 2, and 3, right? That's another path that we could have, right? I'm saying, but that's one of the paths. So 0, 1, 3, and 2, right? That's a path that we printed, guys. So that's how the whole algorithm would have worked, guys. So we're gonna jump quickly into the code right now, guys. I'm saying, hey guys, yeah. So right now we have, I've told you guys, we have a DFS function, right? So this is the function that we're gonna use. So in the function, right, we have a stack, right? I'm saying, then we have the graph, right? So right now this function accepts, right, a list of edges, right? I'm saying, pretty much, you know, we're gonna represent the graph in a agency list format, right? So if you guys don't know what I'm talking about, I did a video on that, right? How we represent graphs, right? So I highly suggest you guys go check it out if you guys are not familiar with that yet, right? I'm saying it's key for you to understand what I'm doing, guys. So I'm saying, and then yes, after I build the graph, right, build the graph, right, and then now I start off with a social node, right, which is 0. I'm saying it could be whatever node you want it to be. I'm saying. And then we have a set, guys, to let us know like the node that we've seen before, right? And then while the stack's not empty, guys, we process nodes one by one, right? And then if we've already seen that particular node, right, we skip it. You know what I'm saying the same thing that I did in the walkthrough, right? And then set, we add it to the set, right? The node to the set, so we don't visit it again, right? And then we print the node, right? I'm saying that's what we're doing, right? We print the node, right? And then we visit all the node's neighbors, guys, what I'm saying. And because of the nature of the stack, right, we go deep into a path as much as possible, I'm saying, because the stack is less than, right, first out, I'm saying. So yeah, so right now let's quickly run the code, see if we pass. You see we have a path, right, which is exactly, guys, we have 0 1 3 2, right, which is exactly, guys, what I'm saying, exactly the path that we did when we did the walkthrough, guys. So you see that, you know, it is matching what we said, guys. So 0, I'm saying exactly what we have here, guys. So pretty efficient, pretty amazing, guys. So yeah, guys, I want to thank you guys for watching this video, guys. If you guys found value, please give me a like. I'm saying we really appreciate it. If you guys are new, subscribe to the channel. And yeah, I want to say thank you guys for watching, and see you guys in the next video.